Okay, so question 90, the key is to start off with by drawing f of x equals 1 over x squared, and that's what it looks like, okay? And if you can't quite remember the sketch of it in the exam, always think back to 1 over x, right? Okay, so we should know that one there, 1 over x is this curve here, okay? And in the negative x values, we've got negative y values, yeah? Because when x is negative, 1 over negative will also be negative. Okay, however, when it comes to 1 over x squared, well, it doesn't matter for negative x values, okay? But if you're squaring the x, it's going to make it positive, isn't it? So what actually happens is very much like the 1 over x graph, but this negative out here will get flipped to make positive, okay? So it gets reflected in the x-axis, hence why we get that then, okay? And then, you know, these will never get to the axes, okay? They'll never get to the axes here. The axes act as like asymptotes then, okay? It gets ever so close here, because as x gets really big, okay, as x gets very large, of course you're dividing 1 by a massive number. It's very small, it's not 0, it's tending towards 0, okay? So in part 1 then, they ask us to draw f of x minus 4. So of course, in terms of the transformation here, it's a shift down, isn't it? It's a shift down by 4. And you need to appreciate then, because this never actually gets to the axes acts as an asymptote. But if you then shift it down 4, okay, we need to have sort of an asymptote in place then. So what I'm going to do here, I'm going to draw an asymptote, because it's shifted down 4, and draw an asymptote in here. And remember, an asymptote has got a broken line, okay, like that. Okay, and it's important that you do put in the value then, minus 4, to show where it is. And simply then, we sketch that graph then. This graph here is being shifted down 4. So I'm going to turn the paper page around. Kind of easier for me to draw that there. And it's kind of like that there. Okay, and of course then we've got the negative of it. Negative x values there. Okay, fantastic. So then we've got that, and it says then, of course, hence solve when f of x minus 4 is equal to 0, yeah? So what I'm going to do then is, because f of x, remember, is 1 over x squared, okay? It says 1 over x squared then minus 4 equal to 0, okay? So that's what we want to solve here, doesn't it? That's what the question says, hence solve this. In other words, where does the graph cross the x-axis here when it equals 0? Where does it cross? Well, if I put 1 over x squared in here, take that minus 4 over the other side, so I get that. Then what I can do, because x squared's on the bottom, take it up, so I have 4x squared, take the 4 down then and divide. So I have 1/4 equals x squared, and to get x then, all we've got to do then is take the square over and square root. So if you square root a quarter, you'll get a half. But of course, don't forget, when you square root, plus or minus, yeah? So you get x is half, or x is minus a half. Okay, so we're going to have a half there, or minus a half there. Okay, so on to the next bit then, alright? Minus f of x, quite simply here, minus f of x is reflecting in the x-axis, okay? Because what you're doing with minus f of x is you're making all the positive y values here negative, okay? So here's your y values. If you chuck a minus in front of it, they just all become negative. So that reflects in the x-axis there. Okay, draw it like that. Something like that. I'm sure you can do a better job than me. F of x plus 1, and remember this is a shift in the x direction because it's in the bracket, it affects the x values. But remember as well, in the bracket we always do the opposite, so we're actually shifting to the left, okay? So we shift to the left by 1. Okay, we're going in the negative direction by 1. So this graph here gets shifted to the left by 1, so the asymptote then, the y-axis, gets shifted to minus 1, so I need to draw an asymptote there at minus 1. And I can then draw in my 1 over x squared okay, so we've got our graph looking like that now, where we do have an asymptote at minus 1.